Good day, everyone. Today, we're presenting our project titled MedVault, which is developed under the guidance of Professor Raparthi Yashwant from SCOPE at Vellore Institute of Technology. Our team consists of E.B. Yamini, myself Divyendu P., Pooraja S., Geetapriya S., and Monica S. This presentation contains the following: introduction, importance of application and related work, gaps in problem statement, objectives, existing model, proposed model, and conclusion and references. Introduction. Today, patient data is often scattered across different hospitals, making it difficult for doctors to access complete medical histories. A blockchain-based system can solve this by giving each patient a universal ID linked to all their records. Hospitals can securely access and update information in real time, even if the patient visits a new hospital or forgets documents. With smart contracts and strict access control, only authorized providers can view sensitive data. Since blockchain is decentralized and tamper resistant, it ensures secure, transparent, and reliable sharing of patient information, which will improve care and reduce redundant tests. Importance of application. The main goal of this application is to create a universal patient ID for seamless access to medical records across hospitals. It enables real-time data sharing, helping avoiding repeated diagnostic tests and improving treatment accuracy. Smart contracts add role-based permissions, which ensures fine-grained access control. Blockchain's immutability also reduces the risk of tampering or unauthorized access. And most importantly, it supports emergency care by making verified patient data instantly available, no matter where the patient is. To explain the literature survey and summary of gaps, I will now pass it on to Geeta Priya.
What? For the research work, we have reviewed 6 research papers and we have found the adapted methodology, features, and challenges. And moving on to the summary of gaps, it's basically poor integration and interoperability. That is, with the existing healthcare, how poorly it's integrated, and then no robust recovery methods for lost or stolen identity wallets. That is, if a patient loses their private key or identity wallet, they may permanently lose access to their medical records. Performance issues under high load when like many users try to access at the same time. And vulnerabilities in smart contracts and off-chain storage security remain underexplored, which is like flaws in smart contract code could lead to unauthorized access or manipulation of the data. Moving on to the problem statement, our problem statement is to design a blockchain based system for secure and unified access to patient medical records across the healthcare institutions. The objectives of our project is to explore the potential of blockchain technology in enhancing healthcare data privacy and interoperability. That is to enhance privacy and interoperability. We explore blockchain to improve privacy and seamless data exchange in healthcare. Also, decentralized healthcare system. That is, we build a secure decentralized system for managing the patient records. And our framework ensures adherence to healthcare data protection laws. Smart contract automation, that is, we use smart contracts to automate healthcare supply and consent processes. Patients have full control over who can view or use their own medical records, and authorized uh, providers can access up to date and unalterable patient data. And also, patients get notified whenever their records are accessed or changed. Patients can, patients can choose to share their only like the specific parts of their records. For the existing methodology, we Yamini will take over it.
And now coming to existing methodologies. It is divided into two main phases. One is indexing and another one is accessing. On the left hand side, when a e-health record is created, The patient generates a unique signature, a string only that they can produce. This signature is sent to the clinic, which links it with the corresponding health record and publishes this association on the blockchain, making it tamper resistant and traceable. On the right hand side, when a health record provider needs to access the patient record, the patient first authenticates through an identity provider, which issues an assertion, a token providing that patient identity and consent. The doctor receives this assertion along with the patient signature and uses this blockchain to locate references to the patient e-health records. This assertion then serves as a proof of authentication, allowing access to the actual records stored in the clinical systems. This setup ensures secure, decentralized indexing and controlled access to sensitive medical data while maintaining patient ownership and privacy. And now, coming to proposed methodology. On the left, we can see three main user roles. The patient, who can access their health records securely, the doctor, who can view records and request access to the patient data, and admin, responsible for managing the system and ensuring smooth operations. And in the front end, it is built with HTML, CSS, and JavaScript. This is the interface where all the users interact with the system. Before any data flows to the backend, the authentication layer ensures sessions using JWT tokens or session management. Backend powered by Node.js and Express, it handles controllers, services, and enforces access control based on user roles. The backend connects to the several external systems for the robust data handling. One is AWS S3, which encrypts and stores patient records, and MongoDB Atlas stores users' metadata and logs. And the blockchain part, the Ethereum blockchain, records access logs and hashes for auditability and tamper-proof records. And finally, the monitoring layer keeps everything in check. Using CloudWatch, it audits and ensures compliance across the backend and external systems. This horizontal architecture ensures that the MedWorld is secure, transparent, and efficient, proving peace of mind to the patients, doctors, and admins alike. And the technologies that are used to be will be continued by Purvaja.
Today, I'll be presenting the technologies to be used, hardware and software requirements, as well as the state- status of the blockchain. Technologies to be used. Blockchain platform, we are using Ethereum. Smart contracts, we are using Solidity. Front-end, HTML, CSS, and JavaScript. Backend, Node.js with Express.js. Cloud storage, AWS S3. Database, MongoDB Atlas. Encryption, AES 256. Cloud platform, AWS. Monitoring, we are using AWS CloudWatch. And serverless execution, we are using AWS Lambda. Hardware requirements. For hardware requirements, for development purposes, we are using processor Intel i5 or i7, RAM 8 GB, storage 250 GB SSD minimum, internet stable broadband connection. For operating system, Windows 11 or 12, Windows 11 or 10, Mac OS or Ubuntu Linux. For production purposes, blockchain node servers, 8 plus core CPU, 3 GB, 32 GB RAM, and 1 TB SSD. Backend API servers, 4 to 8 core CPU, 16 to 32 GB RAM, 500 GB SSD. Database and storage, cloud-based, MongoDB and AWS S3. Client devices, standard desktops or laptops with modern browsers. Network, high speed and secure,
And security hardware, firewalls, hardware security modules, HSMs. For software requirements, blockchain and smart contract, Ethereum, and Solidity for smart contracts. Um, Front-end development, we are using HTML, CSS, JavaScript, and React.js. Backend development, Node.js for APIs and server login. Database and storage, MongoDB Atlas for cloud-based database, AWS S3 bucket for encryption medical records. Security and encryption, AES 256, bcrypt for hashing values and of passwords in MongoDB. Cloud and deployment, AWS for hosting front-end, back-end, and database. Development tools, Visual Studio Codes, Git, GitHub. Status. National status. The Ayushman Bharat Digital Mission has introduced a healthcare ID system which lays the foundation for secure blockchain-enabled record sharing. NITI Aayog, along with industry partners, tested the MediLedger pilot to ensure drug supplies chains, transparencies, and prevent counterfeit medicines. State governments like Andhra Pradesh and Telangana have launched blockchain pilots for hospital records management and land registries showing government interest. These pilot demonstrates blockchain's potential to ensure tamper-proof health records, reduce frauds, improve administrative efficiency. Large-scale adoption is still evolving, mainly due to the scalable and regulatory challenges. However, with government's strong push towards digital healthcare, blockchain-based systems like our project are well positioned to become a part of India's healthcare ecosystem in the future. Thank you. I'll be passing it on to Monica for international status and conclusion.
So the next slide will be international status. International challenges will be in next level. There are several challenges. Different countries have their own data protection laws. And these variation makes it difficult to create a unified global blockchain system. Currently, no universal standard exists for blockchain based health records, which limits across borders. We all face the data sovereignty rules. Patient data must stay within national boundaries, which conflicts with data science and blockchain's decentralized nature. On the technical side, blockchain still struggles with scalability, high transaction costs, latency, and recovery problems when digital identities are lost. Despite these hurdles, blockchain can still be deployed internationally, but with some drawbacks. We have compliance difficulties and security concern, especially around smart contract and off-chain storage. That's why in practice, blockchain adoption in healthcare today is most commonly within national systems or control circumstances. Our project proposed a secure, decentralized healthcare data management system. It uses Ethereum contract and encrypted cloud storage to ensure data privacy and real-time access across hospitals. For deployment, we rely on tools like MetaMask for identity verification, MongoDB Atlas for database management, and AWS for scalability. So the benefits of this will be our project is a system that reduces redundant diagnostic tests, supports emergency care, and improves inter-hospital coordination. By enhancing data interoperability, it empowers healthcare providers with instant, secure access to patient record, ultimately transforming healthcare into a more connected and efficient system. So the project that we are proposed here, it the main aim is to use the Ethereum smart contract and encrypted cloud data storage for ensuring data privacy integrity in real time across all. So, the conclusion of this will be while global blockchain deployment still faces regularity and technical barriers, our proposed system demonstrates how decentralized technology can strengthen national healthcare systems today and pave the way for more secure and sufficient global solution in the future. Thank you.